All right, let's get going. I'm going to do a double start. So first, good morning. Welcome to Chem 1211 with your host, me, Dr. White, on this sort of overcast Monday morning. All right, if you like what I did this semester, go to ratemyprofessor.com and let them know. If you didn't like what I did this semester, go to ratemyprofessor.com and let them know. Also, if you really like what I did, send an email to the Board of Trustees and copy the president of COD. If you really didn't like what I did, do the same thing. Another thing, uh, and I got an email from the school that asked me to push it, so I'll push it. And that is, don't forget to do your student evaluations for Dr. White. And those are totally anonymous, just like on ratemyprofessor.com. And also, if you ever send an email to the Board of Trustees, that will be kept from me. But I thought I'd get that out. And with that, I'm going to start again. Good morning, everybody. Welcome to another exciting morning of chemistry, Chem 1211, with your host, me, Dr. White. This weekend, I spent grading, and all of you should have seen your test scores and your extra credit score if you handed in an extra credit project in Blackboard. Also, I have emailed you yesterday your individual test points on test number, I gotta get that fixed, 4. And this morning, I will be going over test number 4, but I will remove that from the video. Now, before we get into that, there's some important things I have to talk about. This is our last week together. Oh, I'm sad. I wish I got to know more of you better. That's one bad thing about Zoom classes. But I got to meet a lot of nice people this semester. All right, this is our last week together. Today and Wednesday, I will be doing my world famous review. Excuse me, I'm getting all choked up over for the final exam. I'd highly recommend you come to class, which you have. Also, I'll be posting it on YouTube. The other thing, we're done with the labs. If we were face to face, I like that, face to face. I'll have to use that more often. No, I won't. But anyways, if we were face to face at COD, this week would be lab checkout. And I tell you people, if you want to stop by and say hello to Dr. White, you can during the lab. If you don't, I'm going to check you out anyways. It's quicker for me to do it than you to do it. And also, it's less hassle for all of us. So essentially, there'd be no lab this week. However, since we're on Zoom and you don't have to check out of Beyond Lab Z, what I will do on both Thursday and Friday is open it up to everybody. And on Thursday and Friday, I will spend an hour each day, approximately 50 minutes, and doing practice problems that you might want to watch me do for the final exam. Now, for those of you at lab on Friday, you can use the same login and password. I kept that a secret from you on Thursday. And for those of you who have lab on Thursday, you can use the same login and password to come Friday. And that's what I'll be doing this week. Now, over the weekend, I posted important information about the final exam, and I'm doing something different. You all should have gotten an email. Remember, you should be reading your student email. Thumbs up, people. Did you see Chem 1211 final? Thank you. All right, let's go through this. Uh, I got an email. Hold on, let me stop sharing for a second. Last week, end of last week, I got an email from the department chairman, not only me, all chemistry faculty, reminding us next week is finals week. And we are to schedule our final during the time in the final schedule, which I will follow because Dr. White doesn't need to get in trouble. I can do that on my own very easily, but I don't need extra help by not following the rules, and I will. So next week, we have, not this week, next week, finals week, we have no classes, period. Nobody does. We have final exams, and I will be sending out the email at the, or a little before the start of Monday, 10 a.m., because that's when we're scheduled to have our final. And let's go through that. All right, the final will be next Monday at 10 a.m. At that time, I'll email you the password for the final exam PDF. Now, unlike other exams, and because of my schedule during finals week is quite ridiculous, and to help me out, you have until Monday that day, 1 p.m., to take the final exam and upload your answers to the final exam as a single PDF file to Blackboard. Look at, listen closely. I reserve the right to subtract up to 50 points for anybody who doesn't follow instructions. In other words, upload it as a PDF file, or you're late, really late. I don't want to see any finals coming to me on Tuesday morning. So get it on time. Now, the final exam has 17 pages. Relax. I'll explain this in a little while. 46 problems. There are 8 multiple choice, and some of the questions are multiple parts. Now, the point breakdown, material from test 1, 53, test 2, 60, test 3, 49, test 4, 42, new material, nuclear chemistry, 6 points. If you notice, it adds up to 210, which means there are 10, yes, 10 bonus points. Now, while I have you face to face right now, let me explain about the final. If you haven't figured it out by now, I've taught Chem 12, 11 a number of times with COD. So I know what I'm going to say with a lot of experience. My final, 99% of the students, even though you're given, if we were face to face, an hour and 50 minutes, most students are done in about an hour and 15 minutes, an hour and 20. So just like my hourly exams, I don't write them, so you can't really finish them. Now you'll have plenty of time to do it. And but get it uploaded on time. Now, when I say test material 1's 53 points, go back and look at what was covered for test number 1, and those areas, 53 points will be that. Test number 2, 60 points will come from that. All right, now, important, I would highly recommend that you look at in the lecture folder, important information, final exam. And this will show you what you don't have to memorize, because I've cut back heavily a year and a half ago on, that's almost 2 years now, what students have to memorize. Like I don't ask you to memorize PV equal nRT. I give it to you in important information, but you still have to know how to use it. I would recommend that you download the final exam periodic table and the instructions in case you need it from the assignment area. This should be really Sunday. I'll have to change that, or Monday morning or Sunday. I'll go back and change this. And you should also practice, if you haven't by now, I think you all got it down, making a single PDF. If you have any questions during the test, please email me on your, this should be changed to Monday also, because this is what I did last semester when I had to give it on Tuesday, because that was the final exam. There are no Zoom lectures. I will be having my office hours because the other school requires me to. They don't have what's officially a finals week. So if you want to stop by, say hello, but I will not be at the Zoom class meeting. Now, I do promise by the Sunday after final exam, and that would be a week from this Sunday or earlier, I will post in Blackboard all your points, all your final scores for the final exam, your final total, and your grade. I'll also post it in my COD or whatever they call it. Well, actually, we don't do it that way. Post it so you can see it officially, but what's in Blackboard is officially. All right, couple things. First of all, how do you study for the final? One, you come to when I do the review and watch it and pay attention. Two, use the 4 hourly exams that you have that I went through with the answers to use them as practice problems. Am I going to use the same problems on the final? No. Am I going to use similar? Of course. Hold on. I have an itch. Back to work. And I'll use similar, just like my practice problems were similar on the hourly exams. And that also would help you. Now, I'll give you this information, and that is one, there'll be 4 balanced chemical equation problems on there. You should know how to use that. And I would look at the major problems from the 4 exams and know how to do those type of problems, which I'm just doing common sense. But, oh, it's time for a public service announcement from Dr. White. Here's a life experience that I've said before, maybe, but I'll say again, the best mentor I ever, one of the best I ever had in my life, the late Sid Shapiro, when I started out in industry at AXO, he was my mentor there, and he taught me common sense is not common, and it's true, but still, you can still use common sense and do that for the final. The one other thing I will do, and I'll promise each and every one of you, I do not hand back tests, and I do not hand back, like I've done the hourly exams, the individual point breakdown. When we're face to face, I don't hand back the final. If you have a dispute with the grade, we go to the dean, then I show the final. But what I will do, since you're not doing this, and I also do it when I'm face to face, if you're within 10 points of a cutoff, when I go to issue the grades, determine your grade, I automatically go back and regrade your final to find out, well, did I make a mistake that could help boost your grade? And the answer is, in real life, the most I've ever seen when I've gone back and do that, and I've been doing this for a number of years, is once in a while I'll make a 1 or 2 point mistake. On a rare occasion, 3 points. I've never made a mistake on a final that affected a student's grade, but I still will check. All right, any questions about the final exam? You all should have had your email, in your student email, the announcement I just went over. I'll change on there. I know you'll get a new one where it says Tuesday. It really should be Monday. I thought I caught all those. Bad, Dr. White. All right. Good news. Y'all got back test number 4, and seems like all of you do well in acids and bases and equilibrium. You have noticed there was a heck of a lot less math on there, which historically students do better when there's less math. But what I'd like to do right now is any questions? By the way, this will count as my review for test number 4, because I just did it last week and I just go over the main problems now, which is why I go over tests. Any questions? Looking out into the peanut gallery. Oh, I just did a generation gap. How many of you know what the peanut gallery is? Oh, I see 1 or 2 hands up. It's from Howdy Doody. Anyways, all right. Now, an important question all of you should have is, how am I doing on this in this class? And more importantly, how many points do I need to get the grade I want in this class on the final? And remember, the final exam is 210 points, which is the same as like 2 hourly exams. Back when I was an I haven't done this all semester, but make me sound like an old man. No, I'm not, but well, anyways, back when I was a student at IIT undergrad, we had two exams, the midterm and the final. And depending on your instructor, the midterm and the final were either 50% of your test, that was a lot of pressure, or even worse, the midterm was 40% of your grade and the final was 60%. And finals week was not a pleasant time at IIT because a lot was on the line. But our exam is only worth about 30%. But let me go through the following and pay attention. What I'm going to be doing is based on the assumption that you've handed in all your labs. I'll say that again. What I'm doing is based on the assumption you've handed in all your labs. And the way I grade, most of you, like all of you, have handed in your labs, have gotten decent scores. This semester, I haven't given out any 1s, 2, 3, 4, 5 point on it, even 6. Which means Dr. White's been pretty generous. All right, everybody see the white screen, the whiteboard. Thank you. If you look in Blackboard, I've already posted it. What's your sum of your 3 highest tests? I have my spreadsheet automatically calculate that. And if you look at X, X is the sum of your 3 highest tests, plus if you did the extra credit. Now, for an A, how many points needed? Take 450 minus X. And that tells you how many points you need on the final exam. For a B, 400 minus X. For a C, 350 minus X. And for a D, 300 minus X. So let's say you've done real well and you got 300 and you didn't do the extra. Each exam, you got 100, 100, 100. So X equals 300. So therefore, to get an A, it would be 450 minus 300, which is equal to 150. And you say, oh no, 150. But if you divide this by 2, that would be the same what you need on an hourly exam, which would be 75. But actually you need 150 points. And you can do the rest for the others. And that's how you do it. Now, important, this is based, you've handed in all your labs. If you haven't, then you just got to do your totals and use from my syllabus, I believe it's 630, and you need 90%. So 90% of 630 minus all your points, and so on. But this works if you've handed, and most of you have, which is a good thing. Now, word of warning. A number of you are in a really good shape to get a good grade. Thank you. Makes my heart feel so good. See, it's smiling. Oh, that was awful. Oh, a new emoji, a smiling heart. I'm going to have to patent that. But anyways, most of you are doing very well. And I've seen this happen too many times over the years. Students come into the final, say, oh, I don't need that many points. And they don't study well for the final. and they blow it. Did I still use the term getting a bad grade blowing the final? If not, I just taught you something new. And they get a very low score in the final because they didn't bother studying. And guess what? They lose a grade where they should have gotten, say, an A, they got a B, or I had more than one student's getting a C. I mean, they really didn't study. No matter how many points you need, my advice to you is study like you need every point. And that way you won't be disappointed and you'll do good on the final. You'll be happy and I'll be happy. And that's my advice to you. Because like I said, I've seen students where they need 150 or 140 points out of 210. They say, oh, I don't have to study hard. And they get 105 or 95, and that they get a lower grade or two lower grades. Don't study like you need every point. Now, once again, how do you study for the final? Come to my class today and Wednesday. Also, it would help come Thursday or Friday or both days in lab because we're having open show up and I'm going to do some practice problems like I did last week with the mold problems in each lab. And use your hourly exams and practice. All of you practice all semester with the practice problems. Don't stop. Go back and take the test. Look at the key problems on there. The big point stuff would help, and even the smaller point stuff. And that's it. Any questions? All right, let's see how we're doing time-wise. Quick question for all of you, and I'm going to put out, are you done, but answer it, the poll, yes or no. Did I teach you guys how to clean a bathtub or bathtub walls with a lot of soap scum on it, super quick, like about 5 minutes total of your work, 10 minutes? All right, let me do that right now real quick, and then we'll take a break. You haven't figured out by now, Dr. White's an organic chemist, and I know organic chemistry quite well. And one day, a number of years ago, the one thing I hate the worst in my house, the worst, is cleaning the bathtub and the wall in my main bathroom. It's got that soap scum, and I hate it. It was all that scrubbing and everything. Finally, one day I said, wait a second, you're an organic chemist, you're a chemist. There's got to be an easier way. And I don't like CLR because I don't know what the heck's in there. And that scares me when I don't know what's in it. It's hard to track down ingredients because they could be strong. So I thought about it. And what is soap scum? And this I don't teach here. I teach in organic chemistry. That's not what I want. And soap scum, soap, R means this carbons. Bar soap especially is this structure. It's called a sodium carboxylate anion or carboxylate anion of fatty acid. And in your water are calcium cations, and what it forms is this soap or scum. Isn't that scientific? And this is a solid on your wall, plus sodium ions. Actually, there's more to it, but so the question is, how do you get rid of this? Well, this is a base. And if you add an acid to it, you'll break it up to get back your carboxylic acid. That's what this is called, plus calcium cations. And it's a little more complex than that. So one thing, if you go to the internet, you'll see people use vinegar, which has acetic acid. That will do that. But the vinegar is quite weak. It's only 4%. So how do you ensure that you do it real good? Everybody see? Oh, let's see. No, you don't. Everybody see on the screen, Barkeeper's Friend? This is a product you can get at Jewel, at my local Valley. You can get it at Walmart, and I believe Target too. Anywhere you can buy it. And it's a mixture of what's called oxalic acid and soap, uh, a certain type of soap. And it's got a much higher level of acid than vinegar. And the way I do this, and it's a powder, and it's not that expensive. I have my house, the large can like this. I keep a couple extra. I got one by upstairs by my bathroom and two backup whenever I need it. And how do you do that? It's real simple. Now, my bathtub upstairs, my master bathroom, I have one of those shower heads you can take off and hold by your hand. And so I turn on all hot water, then I spray down the wall in the bathtub, wet it with the hot water, shut it off, take some of the Barkeeper's Friend, and shake it on there. And with a paper towel, not a sponge, because sponges get fouled up too quickly, I just rub a slight paste, a wet paper towel, all over. Then that takes about 3, 4 minutes, if that long. Then I let it sit for about 10 minutes. And what you don't know is well, you do know not all reactions are instantaneous. This gives it time to react. Then afterward, if there's really tough spots and you can see before you clean it, it's really caked on. Know the 3M green pads. First of all, I've learned to cut them in strips so you have to use the whole one and they last longer. You wet it, put some Barkeeper's Friend, just scrub it. And you only have to scrub this part on the real bad ones. And that takes about 3 minutes, my really bad. And as I looked this morning when I took my shower, don't they look nice and clean? By the way, taking a shower is chemistry, organic chemistry. How you get dirt off you is organic chemistry, but that's another class. What happens is I looked and said, it's time to do it. And probably this week I'll be doing it. And after I scrub it for a couple spots for about 2, 3 minutes, either use a scrubbing pad, those 3M, and cut it up so you don't waste the whole thing, or a good strong paper towel that's wet with a little, and 3 or 4 minutes, if that long, take my shower head off, hot water, down the drain, spotless. Actual time to do a really bad encrusted yucky tub, my actual work, 3 or 4 minutes, which is a lot better than spending 30, 40 minutes scrubbing your brains out. With that, that's my gift for you today. It's time for a break. Come back. Well, I went a couple minutes over. Come back at 11 o'clock. That's when the big hand is on to 12. Excuse me. Oh no, I'm late. I'm late for a very important date. Everybody know where that came from? Let's get going. All right, everybody back? Everybody's back. All right, let's get going. What I'm going to be doing next today and Wednesday will be a review for the final exam. What I'm going to go through is the review for each test, but I'll give you some extra stuff. Thank you, Gabby. Speaking about Alice in Wonderland, if you haven't looked at Dr. White's favorite music list and all that, which is on Blackboard, one of my all-time favorite songs, and I actually heard it live, was with Gracie Slick and the Jefferson Airplane, Go Ask Scarlett, or is it White Rabbit? I think it's called White Rabbit. It's on YouTube. I think everything's on YouTube except my high school graduation. All right, let's get going. Everybody see test one review on your screen? First of all, let me make it larger. Again, everything I'll show you during the review is available on Blackboard, has been. All right, long time ago in a galaxy far, far away, for those Star Wars people, I talked about chapter 1, the branches of chemistry. And they are organic, which is the best, but I'm biased. I'm an organic chemist, inorganic, physical, analytical. And if you remember on test 1, I asked you to name 1 of the 4 branches of chemistry. Most of you made Dr. White happy by putting down organic. Thank you. Now, went through the chemical symbols. If you remember, I didn't ask you to learn the whole periodic table. Let me do something that I will do right now. All right. There you're hiding. And there's the periodic table. And you should know from the periodic table, first of all, you should know at this point, C is carbon, N is nitrogen, Li is lithium, and so on. There are only 39. If you look at chapter 1 or chapter 2 lecture slides, I have a list, and I think I even talked about it in chapter 3. And you should know those. So if on a test, like I did in test number 1, I asked what's the chemical symbol for sodium, hopefully I'll know that's Na. If I ask what element has the chemical symbol Cl, chlorine. Now, I didn't teach you anything else yet about the periodic table, but we'll get to that in later reviews. Kelly, you can find, first of all, review number 1 is only a PDF. That's the only one I made, but these are all in the lecture folder of Blackboard. In fact, everybody see Blackboard on your screen? You scroll all the way to the bottom. You see test number 1, review, important information. Test number 2, review, important information. Test number 3, 4. See how organized Dr. White is? That's because I'm an organic chemist. We are. You believe that? And if you notice all the way at the very bottom, there's important information, final exam. I'd highly recommend before the final exam, all of you look at that and check what you need to memorize and what's on there. You just need to know how to use. Again, the periodic table you've been using all semester, this one, uh, the green one. No, I'm not Irish. Oh, that was an awful joke. All right, let's get back. Next, I talked about the metric system, which is a measurement system. And their key prefixes of the metric system I asked you to learn. A kilo is 1,000, 10 to the third. Milli is 1,000, 10 to the minus 3. Centi is 10 to the minus 2. And nano is 10 to the minus 9th, a billion. Centi is 100. And on test one, I had a multiple choice, which are these, and you had to learn them. It was like you learned there's a kilogram, millimeter, milliliter. All those are important prefixes. Next, I talked about scientific notation. Remember, scientific notation. By the way, I forgot to do this. I'm going to do this real quick. Instead of are you done, did you like what I talked about cleaning the bathtub? Yes or no? And the votes are rolling in, and it works quite well and it's safe to do around the house. All right, let's continue. Scientific notation. That's some number times 10 to another number, let's call it y. N is never less than 1 and never greater than or equal to 10. It's between that. Y can be anything, but it's a whole number. And test one, I asked you, write the following in scientific notation. So I'm going to share some fun because I haven't done it all morning. So write 12000 in scientific notation, which is 12,000. All right, anybody need more time? How do you do it? You look for if there is or if there would be a decimal point, and you move it to the right of the first non-zero number. 1, 2, 3, 4, eventually getting over there. And any zeros at the end with no decimal, you drop. So that'd be 1.2. I moved it 1, 2, 3, 4 times. Times, whoop, I already did it times. Times 10 to the fourth. And that's how you do it. Let's do another one. These are fun. And again, write the following in scientific notation, 0.00340. And remember, if you have any questions, I will have my office hour tonight from 6 to 7:15. And for those of you who don't know, Dr. White's so good at my office hour, it's even a drive-through office hour. Except I don't have the little window to open up and ask for here's your order like McDonald's. I haven't been to McDonald's in I bet a good 20 years and I don't miss it. I'm a hot dog person anyways. All right, let's do this. You move the decimal point to the right of the first non-zero number. 1, 2, 3, 4. When the number is less than 1, it's X, or as I had up here, Y, is a negative number. So when there's a 0 after the decimal point, after the numbers, you keep it. So this would be 3.40. How many times did I move it? 1, 2, 3, 4 again. 10, but it's less than 0 to the -4th. And that's how you do scientific notation. Next, I talked about significant figures. And remember, in significant figures, which I will never ask you to give me the rules, but I expect you to know how to use them. And that is all non-zero numbers are significant. All lead zeros are never significant. Zeros at the end of a number without a decimal are not significant. Zeros at the end of a number with a decimal are significant. And zeros that are between two numbers combined are significant. And a number of you still haven't gotten it, so let's do a few. And for each of the following, how many significant figures are in the following number? Or numbers A, B, and C. And just in case you can't see it, there's a decimal point here, there's a decimal point here, and there's a decimal point there. Isn't it nice Dr. White can make extra large decimal points? That was pretty awful. And by the way, now you're seeing why my reviews help. But I already knew that. All right, everybody done? Thumbs up, people. You know what I haven't done today? And I don't want you to feel left out. Time to go. All right. All non-zero numbers are significant. So here, that's 1, that's 2. Oh, 0 at the end is with a decimal point are significant. So these are. So the answer is 4 significant figures there. Next, B. Zeros at the front of a number are never significant, even with a decimal. Therefore, non-zero numbers are, this has 2, because these are not. Next, non-zero numbers are significant. Zeros confined are significant between two numbers, and zeros at the end with a decimal point. So I have 1, 2, 3, 4, 5, a whopping 6 significant figures. And that's how you do significant figures. Now, as you learned, your calculator gives you a lot more significant figures. And to the final, just like test 1, 2, 3, and 4, under your name, it will say, please use proper significant figures for all calculated answers. And you have to learn how to round it off. For A, round that off to 3 significant figures. And for B, round that off to 4 significant figures so Dr. White can get out of his 3 significant figure rut. That's 7.629777. I still think it's cool to write the sevens the German or Eastern European way, the way I learned in German class in high school from Herr Brink. I wonder if he's still alive. Such a nice guy. Did I tell you people the Batman story from Herr Brink? While you're doing that, I'll tell it to you. This was German class in high school. Ja, ich spreche nur Deutsch. I speak a little Deutsch, nur ein bisschen Deutsch. I actually spoke it when I worked in Germany. But anyways, one day, Herr Brink comes into class. Herr, if you don't know, means Mr. in German. And he was German, which made his teaching even better. He was funny. And he was about 5'7", small guy, but husky. And he said, I saw a great movie this weekend. We asked him, Herr Brink, what movie? And he said, The Fledermaus Man. What? What movie? I saw The Fledermaus Man. By the way, Fledermaus is German for Batman. And he saw the first Batman movie, and we all started laughing. Fledermaus must have been impressive, put an impression. I still remember that many, many years later. All right, let's get back to work. How do you round A to 3 significant figures? Keep the 1, keep the 2, keep the 5. Use the 1 to round off. If it's 4 or less, you drop that and is 1.25. B, 4 significant figures. Keep the 7, keep the 6, keep the 2, keep the 9. Use this to round off. Is that 5 or higher? Yes. So drop that when it's past the decimal. And when you're using a calculator and scientific notation, this is the way you're going to see that. I increase this by 1. That becomes 10, which means I increase that by 1. So this would be 7630, 4 significant figures. And that's how you do rounding off. Anybody want me to do another one? Nope. All right. In that case, I shall continue with the review. Again, a commercial, know the chemical symbols and names. Have you noticed I've used repetition quite handily this semester? Because repetition is good for your grades. Which, guess what? If you get a good grade, I get what I want. You've learned chemistry. See how sneaky I am? All right, chapter 3. We talked about now chemistry. And the first thing I talked about, chemistry is a study of matter and how things change and how you can change. And I didn't ask that on test, but I asked, what is matter? I might have. And matter is something that has mass and occupies space. And that's matter. And just about everything you see, and some things you don't even see. Like, anybody think about if you were out yesterday or saw the winds this morning? Those are molecules moving very fast. They are. All right, next, I talked about the 3 states of matter. And remember, let's do it. Class participation time. Everybody, the first state of matter, and you don't have to turn on your microphone, but don't forget, if you're at home, say it. Don't scare the kids though. First state, solid. Second state, liquid. Third state, gas. And you should know the definition. A solid is something that has definite shape and definite volume. And this is in the lecture slides for chapter 3. but a solid has definite shape, definite volume. A liquid has definite volume, but indefinite shape. A liquid has indefinite volume, but indefinite shape. In other words, takes on the shape of a container. If you had a square glass, if anybody sees where to get square glasses, let me know. But anyways, I'm talking about drinking glasses, not reading glasses. But anyways, that's a liquid. And finally, a gas has indefinite shape, indefinite volume. Again, solid, definite shape, definite volume. Liquid, definite volume and indefinite shape. And gas, indefinite shape, indefinite volume. Next, we talked about physical and chemical properties. And I talked about examples, physical property, what color is the shirt I'm wearing, what color is the car in front of your house, if there's one parked there. Those are all physical properties. Chemical properties explains how something can change. Uh, Example would be uh, gasoline is flammable, uh, and things like that. And then what's a chemical change and a physical change? A physical change is a change of state. Example, when water boils, goes from a liquid to gas. When ice melts or water freezes, goes from a freezes liquid to solid, melt, solid to liquid. What's the chemical change? Would be when you burn something. Haven't figured out all organic chemists who are really good when they're young were really pyromaniacs at heart. Dr. White was. Next, I talked about temperature. There are three scales we use in chemistry. One is Celsius, the other is Kelvin, and then Fahrenheit, which you use in your everyday. And I showed you the conversion factors, which we learned and you've used this semester. Those will be an important information. Years ago, students have to memorize that, and I've cut back on that, as you know. And remember, if you look at the Fahrenheit, do the multiplication before you do the addition. Common mistake is students add 32 degrees C and then multiply the whole thing by 1.8. No, you do the multiplication 1.8 times degrees C plus 32. A more common mistake is for degrees C going from Fahrenheit to Celsius, students do degrees F by 1.8, 32 by 1.8, and do the subtraction. No, you do the subtraction. Now, for all three, 1.8 and 32 for the first two, and 273 for the last one are exact numbers. Again, 1.8 and 32 and 273 are exact numbers. Therefore, for each formulation, the first two number of exact numbers you get in your answer should be the same number as the measurement. The number of significant figures in the answer should be the same for the first two in the measurement. Now, the last one is addition, and 273 is an exact number. And remember, for addition, you get the same number of significant figures past the decimal as the number that has the fewest. So for Kelvin, you look at degrees C, and I'm sorry, just one bad thing about having Adobe, now it's disappeared. How many significant figures past the decimal in degrees C for Kelvin formula is how many you should get in your answer. Remember, addition, you don't change anything to the left of the decimal point. All right, now we finally started getting into some chemistry, and Dr. White had a big smile, and we talked about The atom. The atom is the smallest particle of an element that has all the properties of an element. The atom is the smallest particle of an element with all the properties. Everybody get that down, or should I repeat it again? The atom is the smallest element of particle of an element. Get myself confused. Let me start again. The atom is the smallest particle of an element with all the properties of that element. My mind is racing ahead to the next exciting stuff because I talked about subatomic particles, and the subatomic particles are the particles that make up an atom, and there are three of them. And it's time to do class participation again. Again, you don't have to turn on your microphone, but along with Dr. White. The first one is electron. The second one is proton. And the third one is neutron. And you should know the electron has a negative charge, proton positive charge, and neutron no charge. Oh, let's do it again. Class participation time. Come on, I can see you're not doing it. Everybody out loud. First one, electron. Second one, proton. Last one, neutron. And class, if you didn't do it loud enough, I'd make you do it again. Dr. White's mean that way. Now, when we talk about the subatomic particles, there are a couple experiments you should remember. Hint, one, Thomson's cathode ray tube experiment. And what he did was prove that the electron had a negative charge. How many of you remember the old TV sets with the tube? That was a cathode ray tube. We don't call it that. We call it this a tube TV, which I haven't seen one in years. I'm all LCD and LED, hopefully you are. Now, the other key experiment was Rutherford's gold foil experiment. And he proved that the nucleus was very dense. You should know the nucleus is the center of the atom. The nucleus is the center of the atom, and it contains protons and neutrons. And Rutherford's gold foil experiment, which I think I asked on test number 1, it proved that the nucleus was very dense. Then another question, what subatomic particles are in the nucleus? And those are the protons and neutrons. So, nucleus, center of the atom, very dense, which is what Rutherford's gold foil experiment proved. Now we started getting juicy stuff, and we talked about the atomic number of an element. And by definition, the atomic number of an element is the number of protons in that element. But because all elements' atoms have a net zero charge, that also tells you the number of electrons. So the atomic number tells you the number of protons and the number of electrons in an element. All right, everybody see the periodic table on the screen? Thank you. And if I ask on a test, which I did, how many electrons and protons does nitrogen have? Well, how do you do that? You know the chemical symbol nitrogen is N. In the upper right-hand corner, the atomic number tells you how many protons and electrons. And the answer is 7. And now I'm going to let you try one. How many electrons and protons does bromine have? Time's up. Bromine, Br, it's right here and has 35 electrons, 35 protons. Oh, let's pick another one. How many electrons and protons does lithium have? Everybody looking real close? And the answer is lithium, chemical symbol Li, has atomic number 3. Therefore, it has 3 electrons and 3 protons. Oh, let's do one more. One I pick on, even though I've never used it. Krypton. How many electrons and protons does krypton have? Remember, in our universe, krypton is a colorless gas. It's not a green solid that kills Superman. And krypton, time's up. What's the chemical symbol? Kr. It has 36 electrons and 36 protons because that's the atomic number. All right, now, when we look at the periodic table, there are key groups, otherwise known as columns. And those are the alkali metals, the alkaline earth metals, the halogens, and the noble gases. Again, they're key groups or families, and those are the alkali metals, the alkaline earth metals, the halogens, and the noble gases. I'll wait until everybody finishes writing it down. If we go back to the periodic table, not including hydrogen, this is important, hydrogen is not included, but the first column right here, lithium, sodium, potassium, the others too, but that's all I asked you to learn, are the alkali metals. Second column on the left are the alkaline earth metals. And those are the only two I asked you to learn from here, chemical symbol wise, are magnesium and calcium. And hopefully you're all getting calcium for strong bones and you're not getting calcium metal, which I taught you later on. But anyways, the second column, alkaline earths. If we go all the way over to the second column from on the right with the number 7 above it, and fluorine, chlorine, bromine, and iodine are the halogens. These are the halogens, which is why if you see the lights, the older lights, halogen lights, because they contain that, usually chlorine, I believe, but don't quote me on that. And finally, all the way to the right, the last column are the noble gases, helium, neon, argon, krypton, and so on, xenon. And another one, I forgot ruthenium, what RN is, I never worked with it. But anyways, if on a test I already asked you, which I did, give an example of a halogen, well, chlorine, bromine would do it. If I asked, give an example of an alkali metal, my favorite, sodium. I like lithium and potassium too, but I like sodium the best. Now you know he's a chemist. Next, I talked about a metal is something that has the properties of luster, meaning you can shine it, thermal conductivity, it conducts heat, electroconductivity, it conducts electricity, and malleability means you can pound it real thin. How many of you have ever seen gold foil? That's real thin. And aluminum foil is made from big ingots of aluminum that they keep on rolling and pressing thinner and thinner and thinner. Ooh, Did I tell you people why only one side of aluminum foil is shiny? Then I won't tell you anymore because everybody's saying yes. And that was test one review. Got a few more minutes, so let's move on to test number two review. Everybody see that on your screen right now? Thank you. Thumbs up, people. I'm surprised nobody drew a little smiley face on their thumb. See what a bad influence Dr. White is? You can go like that and never mind. All right. In an atom, the atom has the nucleus with the protons and neutrons. Where are the electrons? Well, they're all around the atom, the nucleus, in what we call the electron cloud. And the electron cloud exists with different shells, and a shell is where electrons have the approximate energy and approximate distance from the nucleus, and they have fancy names, shell 1, 2, 3, and 4. Now, in each shell, there are subshells, and the subshells are where electrons in a subshell have the same energy and are the same distance from the nucleus. Remember, nucleus, center of the atom, with protons and neutrons. And shell 1 has one subshell. Shell 2, two subshells, 3, 3, 4, 4. And this chart will be given to you. Go look at important information on the final exam. Now, the subshells have names, actually letters, S, P, D, and F, and the lowest energy is S, and as you go to the right, higher energy. Now, the subshells have a limit of how many electrons you can put in there. S, you can put in 2 electrons. This chart will be given to you important information. P, 6, D, 10, F, 14. I'm almost out of time, so I better tell you, don't forget about Dr. White's gift on doing electron configuration, which we'll talk more about on Wednesday. You only have to know how to go up to magnesium. That's my special gift, and that will still be a gift if I put this on the final. And with that, I'm just about out of time. I'll remind you, as the school sent out an email to me and all other faculty, don't forget to do your student evaluations for COD. If you want, don't forget about Rate My Professor and the other stuff too, whether you like me or you don't. See, I'm not pushing you to do one way or the other. And for the person who already did one, thank you. And for the rest of you, thank you anyways for being in my class. And I will see you on Wednesday. If you have any questions, don't forget, I'll have my office hour tonight on Zoom, the same Zoom channel for my office hours I've done all semester. And with that, I'll say, Gang Gazoon, bye.